Hey everyone, welcome to my channel. Today we are going to learn how to run a DC motor with a Raspberry Pi. We will start with the simple test code and then write a motor class using object-oriented programming so that it could be scaled for bigger projects. In other words, you will be able to run and manage lots of motors with just a few lines of code. In the upcoming videos, we will be creating a Raspberry Pi based robot controlled with keyboard, PS4 controller with camera and whatnot. So stay tuned for that and don't forget to subscribe and hit that notification bell so you don't miss out on any of the upcoming videos. So let's get started. First, we are going to have a look at the wiring. The motor driver we are using is the famous L298. It can handle two motors and it has 3 pins for each motor: enable, input 1 and input 2. So let's start off with the coding. The first thing we will do is to import our GPIO library. So we will write import and then we will import our Raspberry Pi .gpio as GPIO. Then we also need the time library because we are going to use the sleep function. So we will import let's just import the function. So we'll say from time import sleep. Okay, so next we are going to set our mode. So we will say GPIO. This is something that you have to do every time. Set mode as GPIO.PCM Broadcom, and then we are going to write GPIO.setWarnings. We are going to turn them off because they are annoying, so we'll put it as false. Then we will write our main loop. So we will write while true. We want to run our loop, and in the loop we are going to print loop running. There you go. Oh, there you go. So let's run that and we have our loop running. Now to run our motor, we have to first declare our pins, and we have to define that all of them are outputs and one of them is PWM. So 2 of our pins are basically for direction, and one of them is the enable pin, which will change our speed as we go along. So we are going to declare our pins as outputs. So we are going to write GPIO.setup, and then we are going to say that our enable pin is out, GPIO.out. So this enable pin we are going to declare now, and then we have the input pin 1 and the input pin 2. So we will write here in 1 and then in 2, and at the top here we are going to declare enable and then input 1 and then input 2 equals to enable pin. Let's put it at 2, then 3 and then 4. So next we are going to define our PWM pin. Now our PWM pin is the enable pin, which is pin number 2. So we are going to write PWM is equals to GPIO.PWM, and then we are going to write our pin number, which is enable, and next we are going to start our PWM with the duty cycle of 0. So PWM.start 0. Now that we are all set up, all we need to do is we need to send the signal, the duty cycle, to our pin number, and we have to define our input 1 and input 2 as high or low based on our direction. So we can write GPIO dot output, and then we have to define our pin number, so that will be input 1, and then we are going to define GPIO dot low. So this will be low, and we can do the same for the second one, and we can say that it is high. So I'm just putting it randomly. You can change it if you want to put low and high or high and low based on your preference. And then we have to define our pin for the PWM. So for PWM we have to write PWM dot change duty cycle. So we'll write change duty cycle, and then we have to define the duty cycle that we want. So we can write here, for example, 50%, so it will move at 50% of the speed. Now we don't just want to do that, or let's just try it out. Let's just try it out first and see if it works. And there you go. So our motor is now working at 50%. If we change it to 100, now you can see it's rotating faster. We need to write the command to stop it. Okay, that stopped. Okay, so what we can do is we can copy this and we can change our direction. So and we can put a delay in between. We can say sleep for 2 seconds and then sleep again for 2 seconds after that. So now what we will do is we will change the directions. So we'll put this as high, up, high, and we will put the other one as low. So this way it will change its direction, and then here we can put, let's say, 50%, and here let's say we can put 100%. And let's try that. Okay, so now this is how you can run a motor, but this is not the best way to approach because you have a lot of code that you will be repeating. So what you can see here, we just have copy pasted our code whenever we want to add onto it. For example, we want to say that go forward, then go right, then go left. For example, for a robot, then that will be really painful because you'll have to copy paste all of this code and repeat the same thing over and over again. So we can do two things. One is to declare a function and we could work that out, or the other way is to create a class and then we can create objects. The better way to do it would be class, so let's try that out. Now if you're not familiar with the object-oriented programming, that's fine. I will be explaining a little bit. You don't need to go into a lot of detail of how it works. Just the basic concept of what we are doing right now should be enough. So what we are doing is basically we will collect all of the code that will be required to run a motor, and then we will create some functions out of this. For example, go forward, go backwards, go left, stop, something like that. And what we need to do is we need to differentiate between the code that is consistent and the things that will be changing for each motor. For example, the code up till here, the first 4 lines should be the same, and they are not related to the motor, so they don't need any changes. So after this code, after this line, everything here is probably is actually related to a particular motor. So what we have to do is we have to put that in a class. So we will write class and we will say motor, and then inside we are going to write nothing. Now we will define our initialization method, which is def init __ and then self, and then okay, let's just do that, and then we will now this is basically the initialization function that will run for the first time when the object is declared. So for each motor we will write motor 1 is equals to this, motor 1 is equals, motor 2 is equals to that. So I will explain that further on. So the first thing we need for each motor, which is different, is these 3 pins: the enable, the input, and the input 2. So what we will do is we will copy this and we are going to write it down over here, and these will be the inputs to our class. So what we have to do is, if we are inputting anything, we have to define it again here. So we will say that self dot enable is equals to enable, and self dot input 1 is equals to input 1, then self dot input 2 is equals to input 2. So what this will do is, whatever we are sending in, whatever values we are sending in, like 2, 3, 4, it will save it for this object. So self just means that instance of the class. So whenever we create a new motor, it will be, for example, motor 1. So we are talking about motor 1 when we are referring to self. And then if we are declared motor 2, then we are when we are using self, we are referring to motor 2. So this way we are getting input from the user as enable input 1, and then after that, so we don't need to declare these anymore. Then we need to declare them as output. So we will we will cut this and we will paste it here. There you go. And then we are going to use, now this enable is the general enable. We need to use the enable of this particular instance. So we will write self dot enable and self dot input 1, self dot input 2. So this way we are declaring all of them as outputs, and then we are going to define our PWM as well. Again, we are going to write it down here. And this time around we are going to write again self dot PWM and then self dot PWM. So here again we have to write self dot enable, and that is pretty much it. Then what we need to do is, now this is for the initializations. Now if I want to do create an object, a motor object, I can just say motor 1, for example. You can name it anything, and then you can write motor, and then you give it an input. So we will write 2, 3, and 4. Okay, so now that we have created our motor, what we need to do next is to give it some functionality. So we are going to create some functions, for example, go forward, go backward, stop, so that whenever we want to access, we don't have to write these 3 lines of code. We can just say motor go forward. So here in our class, we will say, we will write define, then we can say move forward, and in the move forward, whenever you are declaring a function, by the way, in a function in a class is called method. So whenever you're declaring a method, you have to write self inside of it, and then we will close it. Let's separate it a little bit, and there you go. So next we are going to copy this code. We are going to copy this and we will paste it in our move forward. Okay, so once we have done that, the first thing we will do is we will change all of these to self dot. So let me copy this, and we will write here self dot and self dot and self dot. And then once we have done that, what we need to do is this is one direction and the other direction will be the opposite. We will make it high and low, but we need to define the speed. So we want the user to define the speed. So we can say that x is equals to our speed, and whenever the user inputs x, we are going to input it here as x. So the value can range from 0 to 100. But the thing with that is that sometimes the user doesn't want to define anything. They just want to say go forward, right? Move forward. So in that case, we will put the speed as 50, let's say. So it will move at half the speed. So by default, if the user does not write anything, it will be half the speed. If the user writes something, then it will be whatever they write. So also we can add another argument, which is our delay. So we want to move forward, but for how long? So we can say, for example, time is equals to, and we can give it, let's say 1 second, or by default we should give it 0. Then we can write here sleep is t. So this way it will sleep for that number of seconds before doing anything else. So we can copy this function and we can paste it here, and over here we just need to change it to high, and we can change this to low. Yeah, that's pretty much it. So now we just need to change the name of it. So we will say move backwards, and the last thing we are going to define is our stop method. In the stop, we just want to stop the motor, so we have to say self, and then we don't need any arguments, or do we? Okay, let's put in the time as well. So if we want to stop for a certain amount of seconds, we can. So time is equals to 0, and then we can just copy, let's copy these two, and we can write them down here. And let's put it 0, and time is time. Okay, so now we have declared all our methods. Now what we need to do is just call them, and let's see how it works. So what we can do is, okay, let's do one thing. Let me show you how this is better now. So now that we have declared our motor, now motor 1, if we wanted to go forward like this, we can remove all of this, and we can just write motor 1 dot move forward, and then we can just leave it empty, or we can define, for example, we wanted to move, if it's 0, let's put it something, let's put it 30 at the speed of 30, and then we wanted to sleep for 2 seconds, so we will write here 2. So this is now pretty much the same as this, so we can remove that, and then we have this one. So for this we can write motor 1 dot move, let's say, or should we stop? Let's stop first. Okay, let's stop. So we can write here motor 1 dot stop for time is equals to, or do we need to define if it's time, or there's just one argument? There's just one argument, so we don't need to tell, so we can just say 2. And then move motor, so move backwards, and then we are going to save for a speed of 100 and delay for 2 seconds. So as you can see, all of this has now been shrinked down to just 3 lines of code. So writing a class like this really helps out, and let's run it, and I will show you how you can declare a second motor. And there you go. So this is how simply you can actually declare new motors. So what you can do is now to declare a new motor, what you need to do is you will just copy this, and you will say, for example, whatever pin numbers you require, let's say 17, 22 and 25. Now let's write here motor 2. Now what you can do is you can simply say, so you can write here motor 2, and here you can write whatever you want. So now all of the functionalities that motor 1 had, now motor 2 will also have those. So you can say move forward, move backwards, and stop.